right, friends, let's formalize this process a bit more. Over the years that I've taught this, I've learned that students kind of learn hypothesis testing better when there's kind of a plan to follow. So over the years, I've come up with a 10-step plan for hypothesis testing. Please, next thing I want you to do, there should be a template for hypothesis testing. Looks kind of like this in Canvas next to this playlist. Go ahead and crack that thing open, and then we're going to start filling it out together. All right, so here we are in our little Word document, our 10-step plan. A lot of these steps you've already done in watching the previous video, but we're going to formalize it, and we're also going to be using the Excel calculator in Canvas, so we'll get to that in a second too. Okay, so for this first one, we're going to be attacking the problem. We're going to redo the problem we just did, which was the question of, hey, is the flu vaccine working? All right, is the flu vaccine working? And the way we're measuring that, the first thing we have to do is which variable are we testing? There's only two variables that we deal with in Stats 243, and that is the population proportion, and that is the population average. So we are testing the population proportion. I'm going to go ahead and color that red and make the font size larger. That's what we're looking for. In number two, we're going to define that variable. So for us, little p, that's a little p, is going to be equal to the flu rate of those on the vaccine, because that's what we're trying to figure out. We're trying to figure out if the flu rate of the vaccine is less than the general population, which is at 12%. And that's what's going to go down here in the hypotheses. So I guess there's the one. I guess I put 1 parentheses A for research or alternative. Okay, so the research hypothesis is P is less than 12%. The null hypothesis is P is greater than or equal to. I think I can do this. And feel free, if you don't like typing in a Word document, feel free to print these things off and then scan them back to me. There we go. There's our two hypotheses. So the null is that the flu rate of those on the vaccine is no different or even worse than 12%, and the research, which is what the researchers want us to believe, is that it's actually less than, significantly less than 12%. Okay, now let's get into the parts now that we actually didn't do in the previous video. Which distribution should we use for this test? So we're going to learn this right now. You are going to use the Z distribution. Now you might not remember this, maybe you do, from confidence intervals, but Z was the distribution we use for proportions. T is going to be used for means. We'll do that on the next playlist, the next day's worth of stuff. Test statistic and p-value. Test statistic and p-value. Now for these, we are going to go to the Excel calculator and pull these from there. Let's go over there now. All right, so we're in Canvas, Excel calculator. Sure, open a new tab. Someday I'll understand all the ins and outs of Canvas, but it won't be today. All right. Here we go. All right, enable editing, very good. And some of these tabs you've seen and or used before. Group data we've used a couple times, probably use it again for hypothesis testing on a mean. Don't need it for proportions though. Here's all the confidence interval tabs, don't need that anymore. What we want is the hypothesis test for a single proportion. This is the one we want. Okay, now, the only thing you have to fill out, X and N are going to be the two most important values for starters. X is going to be the number of incidences of whatever you were studying that you saw, in this case, flu, and N is going to be the sample size. So for ours, it's 50 out of 500. Okay. Now, the null hypothesis, I put null P, that's the null population proportion, in H0 as a decimal. So the null is 12%. Please notice there's no inequality signs here. It's just simply the number. We'll deal with the inequality signs in a second. So right now, you're all set up. You've got your successes, you've got your trials, excuse me, you got your successes, you got your trials, and you got your null. Okay, these next boxes down here, significance and confidence, honestly, you're probably never going to change those because we generally operate at 95% confidence, which is the same as 5% significance. Very, very nice. Okay, now, this one here, this next little box, this is the only thing you're going to have to change next. This next box is which tail or tails do you want? And you're gonna put an X in one of those boxes, either left, right, or both. It's a little bit cryptic right now, but you pick those based on the symbol in the research hypothesis. So since the research hypothesis for this one is P is less than 12, we are going to place an X in the left tails box. That's the left end. As a matter of fact, I might actually just add, I'm gonna do it right now. Hang on. All right, I like that better. Now we've got the inequality signs where they should be, and this way you can pick where you're gonna put your X based on the research hypothesis. Since we are trying to see if the vaccine lowered flu rates, we're going to the left. That's a less than sign right next to it. Yay, okay, I'm feeling better. Now, if we go to the right on this graph, we'll see a very similar graphic to what we saw before in the Monte Carlo from the previous video that we ran. Now, then it was a little bit different because the axis didn't have zeros, ones, and twos on it and things like that. It had the numbers, the number of people that got the flu. But what this spreadsheet does is it actually normalizes it down so that the average is 0 and any deviations are measured up and down from that using negative or positive numbers. So you can see, since our red area is to the left of 0, that does imply that the vaccine is lowering flu rates. The question is it significantly lowering flu rates? Okay, that's where the results section comes in. If we scroll down here, this is the goods right here. This is the goods. So the results, piece by piece. Here's what we're going to do, piece by piece. P hat, that is the sample proportion. You already knew what that was. It's 50 divided by 500, that's 10%. Less than 12%. Yes, indeed, less than 12%. Is it significantly less than 12%? Well, that's what the next three items tell us. First of all, test statistic Z. This is how many standard deviations away you are from average. You are 1.376 standard deviations down from average in this case. So you're more than one standard deviation away, but not quite two. What does that mean? Well, in order for us to escape the null sampling distribution's confidence interval, we'd have to get past this critical value. This critical value of negative 1.645. Now, if you look at the graph, I don't have these graphed because I'm not exactly sure how to draw this line onto the graph, but that line would be about here. In short, our data did not get far enough down to escape 95% confidence, and you can see that in the p-value, 8.44%. That's very close to that 9% that we got with the Monte Carlo. So basically, the two big pieces of information we need from these results are the test statistic and the p-value. And we're going to come back over here to the template and we're going to add those in. The test statistic with its correct variable is Z equals negative 1.3. I already forgot the rest of it. Z equals negative 1.376. That's how many standard deviations away, and the p-value is about 8.44%. All right, and I remind you what the p-value is here, the chance that your data or even more extreme data agrees with the null hypothesis. In other words, it's the chance that random chance explains any difference. Now, the last part of this is to decide what should we do with the p-value. Well, the first thing is, if we're operating at a 5% significance level, this is above 5%. That means we are going to fail to reject the null hypothesis. Believe the null hypothesis. We're going to believe it. There's no reason to throw it away. It's not a small enough p-value to discard the null hypothesis. We're still in the null hypothesis sampling distribution. So in context, what that means is it does not appear that the flu vaccine is lowering flu rates. It does not appear that the flu vaccine is lowering flu rates. That's all. That's what it means. The only thing I want you to wrap up each of these template sheets with is the error we could have made. And this, again, is very formulaic to what you've done up here. Anytime you fail to reject the null, anytime you get a large p-value, you could have made a type 2 error. You could have made a type 2. Which means we claimed that the vaccine isn't lowering flu rates when it might have actually been. Failing to reject the null means we say whatever we were studying doesn't have any effect, but maybe it does and we just missed it. It's possible that we just missed it. So that, my dear friends, is the 10-step process for hypothesis testing. Roughly half of it we had already done in the previous video in Monte Carlo form. But here, students seem to like this better. They seem to like this strategy better than the Monte Carlo forms. The Monte Carlos are great. I think they're wonderful. I think they're very organic. You get to see the distribution being formed. But at the end of the day, students get this more. This combined with the Excel calculator. So let's do another one to make sure that we make sure this all makes sense.